quick correction. The zero dimension, that's the single point. There's no where it's moving to. It's only in that unit of a point. One dimension is the line, two dimension is the shapes, three dimension is the objects. So yeah. So the universe, as I stated, it that single point, that zero dimension. And when you're imagining a higher dimensional being, you can assume it's a far much bigger organism. Yeah, so a far much bigger organism. But still, not exactly. So either we were looking at dimensions and the multiverse, and we ended up at the universe being this single unit of a point. It can be infinitely big or infinitely small. Just as our universe is, it's continuing to expand outwards. But then there's the microscopic level. So looking down towards atoms and towards subatomic levels, we know that the Planck length is the smallest unit that we consider viable, but possibly this is something smaller, so infinitely small. So that's actually another universe in itself. Okay, so that's where the size comparison comes in. So the universe has this single point, and now the multiverse, it now creates this line, and since there are multiple universes, which is the multiverse, creating this particular line, then they are mirrored. So we're stating where the multiverse are mirrors is like a reflection, and dimensions is like shadows. So it's all a matter of light, how light manipulates certain things. So yeah, when it's reflected upon a particular surface, we get a reflection, and that's a mirror. It bounces back from you, and that's the reflection that you see in the mirror. And for a shadow, it's basically you blocking that particular light. So in our scale now, what could be this particular light that is reflecting the universe that we perceive? So, of course, in this particular universe, it's photons, like ordinary light. And it's from there that we are deriving this example. So it has this particular principle because up to this particular point, up to this far, we've compared the cosmic level and the subatomic level, or rather we've tried to compare the two to delve into both. But the main focus was this particular comparison, how it rather condenses, yeah. Basically in that from the subatomic level, a subatomic particle, or rather something that's subatomic, photons, they are considered to be particles or waves. So these waves, they condense to form the solid structures that we see. And not just the solid structures, also the gases, the liquids, basically matter in itself. But then this particular matter is energy. Einstein's equation, which is E is equals to mc squared. So yeah, condensed energy is what makes up matter. So this particular matter, when it's traveling at a particular acceleration, when it's put under a particular acceleration, it becomes energy. And this particular acceleration, in our current state, it's solid, or rather it's matter. But now we are looking at the cosmic scale. So consider the speeds that we experience. While on Earth, while the Earth is rotating, or rather, okay, we can even consider revolving, we see that it covers many, many kilometers in a single second. But we don't actually feel that speed. But when we are traveling in that particular speed, let's say in a vehicle, we find it to be quite immense, intense. So that's where we're bringing in scale. Right now, we consider ourselves massive, at least compared to photons, which are, we're assuming, energy. So compared to that condensed energy that makes us the atom, that make up the atoms, that makes up our entire composition, if we were to equate ourselves to being that particular size, so assuming the wave is a particle, just as quantum physics does. So assuming that we ourselves are waves, and we look at the entire universe. So that's the same perspective, or rather the same results as what we see when we're looking at photons. So the characteristics that subatomic particles project to us at our particular scale should be similar to the type of effect, or rather results, that we produce to the greater universe. So assuming that we ourselves are those subatomic particles, so to the cosmic being. So the characteristics that we see from photons is the characteristics that we ourselves should be projecting. So why I bring this up is it's been that particular idea has already been portrayed, presented. Let's say presented. It's already been presented to the world. Yeah. So basically, be the light to the world. So you yourself be that particular light. This is that particular example. So what a photon is what you are. So here we're looking at what is above, as above, so below, as within, as without. The where I was mentioning using aspect, or rather, either way. So this particular sphere, where there's good and there's bad, that's where we are. So as above, so below. So as good, so as bad. So it's the same sphere, but then we'll be viewing it at different dimensions and getting a particular experience from it. So yeah, we'll end up saying that something is as it is because of a particular reason, and so on. So, but back to our main point, where that in a particular, we are supposed to be, or rather, we're not, it's not that we're supposed to be, and more of that we are this particular light. So a photon at its particular scale, you can consider it insignificant. Yeah, because it's basically smaller than an atom. The atoms that make us up. But it's what we used to see. Ironically. Is it ironically? It's what we used to see. And it's not the only thing that we used to see, because considering animals that can observe in ultraviolet are those photons. But at this point, let's consider all subatomic particles. So without these subatomic particles, so without these waves, our functioning would be limited, or rather, won't even exist entirely. Like I said, we use photons to see. It's light. There is ultraviolet radiation, something that other animals used to see. And it's also a source of food to plants, a source of photosynthesis. Now we see heat. It's thermal. What kind of? I forget. So yeah, that's another form of radiation, and we use it not just to see, like in pit vipers, but also cooking, because it's fire, it's heat. So these subatomic particles, not subatomic, but rather just waves. These waves, they affect us despite being at their particular scale. And that's where you come in. So at your particular scale, you're able to make an effect. It's not obvious to you, or rather, I won't want to say that it's obvious to you. You'll be basically performing your tasks, duties, wishes. And at the end of the day, you've made an effect. This effect will affect something, despite it not being obvious, or rather not impactful. So here we look at radiation like in a nuclear bomb that will melt a person. So that's waves causing an effect. Well, also heat, but even sound, but basically energy. Yeah. So that's basically it making an effect. But you can be like light, guiding, being a source of sight. So yeah. Well, that's on an individual being light, but we're looking at the dimensions and universes, and we will consider what is this particular light that causes them to come into existence. So yeah, I guess we get into that